I am extremely pleased to have Dr. Kathleen Mosier here today to talk about health-centered technology. Sorry, human-centered technology. I didn't change your talk. Apologize. So let me tell you a little bit about Kathleen's background. Kathleen Mosier is an emeritus professor of psychology from San Francisco State University, and the founder and principal scientist of TeamScape LLC, a company for research on human and human automation teams. Dr. Mosier led an international team of expert human factors professionals in a collaboration with the International Labor Organization, resulting in a joint publication of Principles and Guidelines for Human Factors Ergonomics Design and Management of Work Systems. Dr. Mosier is a NASA-funded investigator, has conducted aerospace research on expert teams, automation, and decision-making for over 30 years. She and Dr. Linda Skitka introduced the term automation bias to describe errors from using automation as a replacement for vigilant decision processes. Her current research focuses on evaluating the effectiveness of new communications technology for long-duration space operations. Dr. Mosier, you have the floor.
And good morning from Oakland. And thank you for inviting me to this conference, Chris and all of you. I'm an industrial organizational psychologist, as Chris said, with a specialization in human factors and ergonomics. I have a few different hats, but today I'm focusing on the hat from the International Ergonomics Association, which is a global federation of human factors and ergonomics societies across the globe. We have about 54 societies and over 20,000 members. IEA is very much involved in the human factors and ergonomics, or HFE, if I can abbreviate, aspects of the future of work, in particular with enhancing human performance and well-being. We collaborate with other international organizations such as ILO, and Chris just told you about one of the products from our work with them. And their mantra at ILO is decent work for all, and that's where their emphasis goes. And we're also collaborating with the World Health Organization to create human factors and ergonomics guidance for healthcare worker and patient safety. So our general goal is worker and work system sustainability and health and well-being and performance overall. So the task ahead, the future of work, is going to require the design of new work systems that incorporate humans and advanced technology. And this, if we're going to do it right, this requires human factors and ergonomics perspectives and principles. So what I will cover today includes HFE and why it is important, issues in human plus technology, work system design, some background on Industry 4.0 and its game-changing technologies, and an introduction to Industry 5.0, which is human-centered work and human-centered technology. We'll talk a little bit about HFE to design human-centered work systems and the characteristics of these kinds of work systems. So first of all, what is human factors and ergonomics? HFE, or some people call it just human factors or just ergonomics, uses theory, principles, data, and methods from a wide range of disciplines, including physiology, cognitive psychology, IO psychology, industrial engineering, human systems integration, sociology, and others. It's an integrative scientific discipline concerned with the understanding of the interactions among humans and other elements of the system. And it aims to look at the whole picture and the interactions among the elements, identifying those that impact on humans and designing or redesigning them for optimal usability and performance and minimal health risks. Ample data show that workers are most productive when all the elements of a work system are designed to fit the capacities and needs of the people doing the work. So it is a core design principle to take these capacities and needs into account. So how can HFE principles and approaches help with the process of creating and using human-centered technology in work systems? First, modern human factors uses a holistic systems approach to look at the whole socio-technical context. The aim is to identify the gaps, that is, the areas where there is a mismatch between the capacities of the workers and the socio-technical context, identify the needs of the system, the risk of errors, and how easily the system can recover from errors. You also need to consider what impact will a given change have on the processes down the line. How sustainable is the work system over time? And when we talk about sustainability here, we're including not only operational sustainability and organizational sustainability, but also worker, physical, cognitive, and psychosocial sustainability. Holistic design and the systems approach is participatory. It's an iterative process requiring a lot of consultation with the workers. They are the experts, after all, who know the job. We heard yesterday about what can happen when these job experts are not consulted. Unworkable processes, often addressing the wrong problems and leaving the essential problems unaddressed. Systems approach is also design-driven and iterative. The iterative part is important, and it is critical to revisit, reevaluate, and redesign work systems over time as they are integrated and we see how they do. So any new technology must be tested and implemented with consideration of the whole socio-technical system within which it functions. The context is really important to consider, and that was brought up yesterday as well. Another thing or factor to be considered is our history, as it provides insights and lessons from our industrial progression. From Industry 1.0 or 2.0, with old forms of power, mechanization of tasks, and first-generation technology, mass production, and assembly line processes. And by the way, some of the surveillance technology discussed yesterday has the potential to take us back to the Tayloristic conceptions of worker performance and productivity, kind of the time and motion, and what are you doing at this moment? What are you doing at that moment? And how does it impact productivity? So focusing on those concepts without much attention to worker health and well-being. So that is a risk. If you go to Industry 3.0, the beginnings of automation, computers, and electronics introduced into work. And then right now we're kind of on the edge of Industry 4.0, on the back edge of it, with innovations such as cyber physical systems, the Internet of Things, and networks. Industry 4.0 has been characterized by digitalization, which we've seen. It transformed industry, accelerated production processes, and changed the role of workers. It transformed and accelerated production and automated many parts of work that were previously done by humans. In fact, to many workers, it probably seems as though the design goal is to replace the human with an automated system whenever possible. And we talked about that yesterday as well, that jobs are getting automated out of existence in some cases. Industry 4.0 also introduced new and game-changing technologies. These are advances with the potential to significantly transform industry and alter our lives. They include sophisticated simulation capabilities, systems integration, the Internet of Things, AI is a biggie, cybersecurity, cloud computing, additive or 3D manufacturing, augmented reality, big data and analytics, and as discussed yesterday by Karen Levy and Lisa Kresge, autonomously operating automated entities, such as robots and vehicles. In particular, the AI, the artificial intelligence, and the autonomous robots and vehicles are changing integration dynamics for human technology work systems, particularly in the performance of work in work systems. So we're going right now from the 4.0, the digital age, to living in a virtual age in which we have increased innovation and possibilities for innovation. We have new ways of working and living. So think of remote work for one, something we would not have conceived of even 10 years ago, doing it as a permanent work style. New technologies and new use cases for existing technologies, artificial intelligence solutions from everything from driving a car to selecting personnel to writing a paper. And we have new digital tools and immersive experiences, such as virtual reality, augmented reality, and virtual collaboration tools. So we really have a new age coming in, quite in advance from the digital age, and substantively different in its qualitative aspects than the digital age. It's significantly different than the past modes that we've had and requires a new unifying paradigm for work and work design. And this is where we can step in and proactively address, well, some it's too late to be proactive, but at least we can step in now and address the issues that we talked about yesterday. What we're seeing in some industrialized nations, and the pictures are from the European Commission, is a movement to Industry 5.0, a paradigm that focuses on the impact of new technologies on jobs, business models, and welfare, and on how workers and automation and technology can function in harmony. It focuses on stakeholders, the people working within industry. According to the European Commission, the Industry 5.0 human-centric approach in industry puts core human needs and interests at the heart of the production process. The well-being of the human is a top priority of the process. Industry 5.0 has a triple mandate for work: to be human-centric, to be resilient, and to be sustainable. From the human factors and ergonomics perspective, Industry 5.0 represents a convergence of industry and HFE goals. It represents a shift in focus from shareholder value to stakeholder value. It places the well-being of the worker at the center of the work process and uses new technologies to enhance efficiency while also taking into account the well-being of humans and our planet. 5.0 calls for a partnership between intelligent humans and smart machines, a convergence of human cognition and artificial intelligence, so that technology serves humans rather than technology being the driver of human activity. All of these mandates are consistent with HFE principles for system design and human systems integration. In fact, HFE has the critical perspective and approach that's needed for Industry 5.0 to integrate humans and new technologies so that technology is human-centered. To reiterate an earlier slide, we use a person-centered approach to the development of human-centric work systems. We want to support human performance, effectiveness, and well-being. We use a holistic systems approach. We look at systemic factors, the holistic perspective, risk, resilience to ensure continuous learning and refinement. We use a design-driven approach based on participation and engagement of all stakeholders. It's an iterative process focusing on whole system design. We identify needs, gaps, and danger points. And it's also a participatory process. We focus on engaging stakeholders in the HFE design process to ensure appropriate and workable system design. And also we emphasize continuous learning. In our approach, we rely on evaluation, iteration, and continuous learning and revising, revamping, reevaluating, and in a cycle to inform us about system success and what needs to be fixed. So what are the basic HFE principles to follow when designing human-centered technology and human technology work systems? One is that the human should always be in control of system functioning and should have the last word and the override. People need to have control and override authority for the technology that supports them and should not be driven by a pace or a practice that is dictated by technology. Key to effective control is knowledge of how the technology works. Early automated technology was functionally pretty reliable, but not very transparent or observable, predictable, or understandable. In my early research, pilots, for example, described their new automated flight systems as magic and often had no idea what they would do next or what they were doing now. This limited their ability to cross-check automated functioning and identify and fix glitches or errors. Basically, they didn't have the information they needed to be in control of technological automated systems. So workers and users need to know how automated systems function, how to verify their accuracy, and how to evaluate their recommendations. The humans need to be kept in the loop with automated systems that are observable and transparent, so processes are traceable and information is not buried as it was in the cockpit under layers of displays. They need to have systems that are understandable and predictable. The workers should be able to know what will happen next and why. And they need, of course, to be reliable. You need to be able to rely on systems and technology to do what it's supposed to do, accurately and reliably. Some ways to keep the human in the loop are to provide process tracing rationale, for example, for decision-making recommendations, and to provide backup cues and information. One important note that was also mentioned yesterday is to avoid leftover design. Because technology can do so much, an easy trap to fall into when automating work systems is what has been called leftover design. So the automation does everything that can be automated, and the human does what's left over. This has several potential consequences. One is boredom or frustration, lack of vigilance, as was mentioned. Humans are not very good at monitoring over a long period. Low job satisfaction. For example, maybe all the interesting parts of the job have been reallocated to the automation, and the human is left with the boring monitoring part. And as I said, humans are poor monitors over time and may start to miss things that are going on. Stress may result from the worry that one is not fully aware of what's going on and what's going to happen. And that may lead to the inability of the human to take over in the event of system failure. So automating easy, normal parts of the work process also means that the human mostly monitors and may be called on only to respond to problem situations or crises. That may lead to slow or incorrect response to abnormal events or system failures. And in aviation, of course, we talk about engine failures, nose down attitudes, all the things that can happen suddenly. The pilot's called in to save the day, but hasn't really been kept in the loop of what the automation's been doing, which has been almost everything thus far. So what can automation do best? If you design so that the automation does what it can do best and what tasks best help the human worker. So automation can, and robots, artificial machines can support the human with physical tasks or repetitive or awkward movements. It can gather and integrate large amounts of data. That's what computers are good for. It's important for the technology to support the front end of the decision process, which is the end where you analyze and synthesize and collect the data and information that you need to assess the situation. So when the automation or technology helps with that, that makes the human a more informed decision maker. When automation or technology is used to provide decision or action recommendations, these should be accompanied by information that enables the individual to trace the decision process. So basically, the human worker should never be left in the dark about what the technology is doing and why it's doing what it's doing. It will be important as work systems are redesigned to involve current job experts and other stakeholders as they offer the insights that you cannot get from system manufacturers who don't know the context or the jobs. And these stakeholders are job experts, the incumbents in job positions, the people that know the job, administrative personnel, decision makers, and other experts and other agents. And these stakeholders can identify tasks that would most benefit from technological assistance. They can pinpoint the gaps and the risks in the system with and without technology. So they can do a lot to contribute to this. They can predict the fatal flaws in the new work system. They can recognize the most critical cues and design features. And importantly, participation in work systems design ensures buy-in from the stakeholders. So in the introduction of technology, if there's not participation in how the technology is designed and how the technology is used from the people that are going to be using it, you're likely to have poor technology fit for the job. And at worst, technology that makes performance worse because it's hard to use or unworkable. The risk of not using this participatory approach is a creation of human technology systems that are cumbersome, unworkable, or seriously flawed. And we were talking yesterday about what are we going to do to fix all of the problems that were talked about yesterday. And I think this is the time that we need to get involved in what we're doing here. Excuse me, I think I lost the screen. Okay, we need to get involved proactively to get workers included in the work system design so that you avoid some of these problems ahead of time. The process is still in a stage of intervention at the beginning. When technology is human-centered, you can think in terms of a partnership between intelligent humans and smart machines, a convergence of human cognition and artificial intelligence or technology. But importantly, this is a partnership that's configured so that technology serves the human workers rather than technology being the driver of human activity. It calls for creativity and improvisation in human technology collaboration. Human-centered work systems call for design that capitalizes on the human ability to personalize and customize work, to draw on their expertise, to think critically and creatively, to problem solve, to adapt to changes and new events, and to make decisions. And it capitalizes on technology's ability to support and assist humans at work, to do all the tasks that I mentioned before that technology does very well. And lastly, the introduction of human-centered technology will be only the beginning of the work system design process. It will be critical to evaluate whether the systems are working as intended and whether there may be unforeseen and unintended consequences of what's been introduced. It will be important to recognize the need for extra time and temporary dips in performance as people adapt to new work systems, and they're assimilated into the workplace. And of course, this redesign will impact how you select new people and how you train for the redesigned jobs. One key consideration will be identifying what skills need to be retrained and what skills need to be retained. And just to add a few of the caveats and the industry comments. So these are coming from a conference on human-centered AI, and things like Ben Schneiderman is one of the people that writes about human control in AI and artificial intelligence systems. It's important to watch out for threats and hazards in these designs. So he says the goal of good technology should be to support users' self-advocacy and human creativity, to clarify responsibility of users and developers and advance social connectedness. I want to see AI infuse super tools that are reliable, safe, and trustworthy. And if it's not reliable, safe, and trustworthy, he uses slightly different words than I did, but they mean the same thing, then shut it down. Another speaker said we need to think about how people are productive, not just how machines are productive. When we put too sharp a focus on productivity, are we ignoring downstream considerations like individual autonomy, freedom, and happiness? Another speaker gave the example of Amazon and UPS, both of which monitor their delivery drivers, but with an important difference. Amazon more often manages by algorithms, and we heard about algorithms yesterday and how they're pluses and minuses and how they can be good and how they can fail. And Amazon's algorithms has led to questionable firings, while UPS data gets reviewed by humans. If there's an error or a grievance, they have a human-centered process in place for rectifying it. So I think in terms of knowing our history, we need to know not only the stages that we've gone through industry-wise, but also the stages that we're going through now in technology design and implementation. And with that, I thank you and left some time for questions. Thank you.
That was an incredible talk, Kathy, and I must say, offers much food for thought here. And it's just so important that we start off today's presentations with this very broad and very central issue of how we make our technology more human-centric. And so I really thank you for laying it all out for us and describing in depth Industry 5.0 and its requirements. So I have a few questions for you, and I want to ask one that is already up here. Okay, so Ed Yellen asks, what are the characteristics of organizations that apply the principles that you described today? Do you have any familiarity with that?
So I do know that there's the International Standards Organization has a standard around human-centered organizations, and it talks about management processes and how management interacts with workers and takes into consideration worker input, asks them for questions, and considers worker health and well-being. So you can kind of look at organizational culture and their mission statements and their goals, and you can get a sense of where their priorities are. And I think one of the key characteristics of the organizations that are open to this is their focus on employee well-being, performance, of course, because the organization needs to be sustainable, but performance and well-being of the workers and sustainability of the workers. So I recommend that. I think it's 675,000 is the number of the ISO standard, and that's a good place to start for those characteristics.
Thanks. That's helpful. And I'm going to ask you a question. So what resistance have you sensed from businesses and other parties to considering work holistically through this systems lens? I know that you and I have
Mm,
talked often about resistance, but for our audience, what resistance have you encountered, and what is your counter
yeah,
to this
yeah.
resistance?
It's amazing to me how that there is resistance, but I think that the human factors principles and practices take a little more time and investment than just buying technology, for example, off the shelf and putting it into the workplace, letting somebody else do all of the figuring out what should go into it without really talking to your specific people that are going to be using it. It takes less time if you just buy something off the shelf and put it in there and hope that it works, basically, or trust that it will work. And the other thing is, I think it's hard sometimes to demonstrate the dollar return on using the systems approach. And it is there. There's a well-known paper that's, good ergonomics is good economics, that talks about the return on investment. But I think when systems are out there and readily available and just off the shelf buy, and you implement things, for example, the truck driving example from Karen Levi yesterday, where you give the workers some technology that helps them count their hours, but there are all kinds of other things that are involved in that too. And if you just buy an off-the-shelf package, you really don't know what you're getting and how it's going to impact the people that work for you. So I think, return on investment is something that needs to be considered. And it is an investment in terms of time, getting experts involved, getting participation. But it's
Great.
worth it, because I think the solutions are here. We're not going to put off these technologies or put them on the shelf to be not used. They're going to be used.
So Victor Rubin asks, with reference to the example you provided, UPS is unionized and Amazon is not. Might that be a key determinant of why they apply monitoring technology in such different ways?
That's a good question. And we've done a lot of work with the ILO, the International Labour Organization, and that's a tripartite organization that focuses on government, organizations, and unions as representatives of workers. And I think that you need to have that whole tripartite thing to create decent work, and could have something about that in there.
Great. And Tim Bushnell asks, the principle that technology be understandable, transparent, and with results that can be checked seems to be violated by the fundamental nature of AI. Do you have any insights on the challenge of getting AI to adhere to these principles? Tough question.
Tough question.
I mean, solve the whole problem.
Yeah. So when you do a search, for example, on an AI, do you go at it and, I guess multiple directions? I don't know. I mean, I'm not a creator of AI, and I just heard today, I read in the Chronicle that the guy who is considered to be the father of AI just resigned from Google so that he could speak out about the dangers of AI without interfering with their investments in it. And I think it's there are several pressure points at which you can look at that. So one is when it's being created. So the creators of AI systems need to be pressured to do that. And then organizations need to pressure the creators to have the systems that they want, that are observable and understandable, before they will use them. And I think it's going to be tricky.
Yeah.
But I think it's essential.
So your work with NASA is kind of unique in the sense that they have bought this hook, line, and sinker because of the critical missions.
They have bought what?
Human-centered technology, and looking at multiple stakeholders and putting the human at the center and so on. And if you could just comment a little bit about how, you know, your work with NASA has been facilitated by a particular point of view of NASA on their projects, such as the International Space Station missions and the lunar habitat.
Mm-hmm. So yes, I could go on for a while about that.
Yeah.
But so aviation is kind of the testing ground for a lot of new systems and a lot of new technology. So as I mentioned in one of my examples, early on, pilots were given a whole bunch of automation and technology without much information about how it's working. And we identified this phenomenon of automation bias, because if you can't see what's going on and it works most of the time, why would you go through the effort of checking it or looking at other indicators? And in fact, if you look at accidents like the 737 that took the deep dives, some of the displays that you could use to double check it were not even included on the airplane unless you paid more. And NASA has always believed in human factors as a priority in the design of everything that they do. And so the work that we do is in the human factors and behavioral performance branch. And when you have to look at the human as embedded in this really sophisticated system. And one thing that is important to know is that even if all the technology is working perfectly, you need to have the humans in there and involved in it, or you're not going to have a successful mission. So I've been really fortunate to do my research in an organization that supports these notions and appreciates the value of human factors and ergonomics and design.
If only we had more organizations oriented the same way as NASA.
Yes. Yeah. In some ways, yes.
Yes, and I'm sure.
So yes.
So thank you, Kathy. I can't thank you enough for being part of this
Thanks for inviting
discussion
me
today. All right.
Thank you very much.